Okay, so today we're going to look at simultaneous equations. This is my second video in simultaneous equations, and this time it's a little bit more difficult. And the reason it's a little bit more difficult is because in my pair of simultaneous equations that I've got here, in my last video I said we're looking for either the one set of letters where we've got the same amount in each equation. So we'll start off again the same way. We're going to label up the two equations, but this time you'll notice that I've got a 2x and a 4x, so they're different, and I've got a 5x and a 3x, so they're different. So this causes us a problem because, as I explained last time, we're trying to do the elimination method, and with the elimination method we want to be able to subtract the two equations so that we can eliminate one of the letters. We can't do that unless we've got the same amount, but there is a way around it, okay? And the way around it is we're going to take this equation here and we're going to multiply it. And the reason I'm choosing this one is because if you look here, we've got a 2x and a 4x. If I multiply the 2x by 2, I'll have 4x. But I can't just do the x, I have to multiply the whole equation, because then that keeps the actual value of the equation the same, and that's what's really important. So we multiply that entire equation through by 2, and we just write it out underneath. So 2x times 2 gives me 4x, 5y times 2 gives me 10y, but it's important to also multiply the constant term, so 41 times 2 is 82. Now I can't call that equation 1 because we've already called that one equation 1, so we'll call it equation 3. But what's really important, and you must understand this, is that equation 1 and equation 3 are the same equation. This one has just been scaled higher. And in actual fact, you can do that with any equation. You can multiply it by any number that you like, but it's a useful thing to do here. So now we're looking at equations 2 and 3. Now we've got a 4x, so if we subtract our equations, then we will eliminate the 4x's. But we've got to do it in the right way so that we don't end up with any horrible minus signs that we don't need. So this time I'm going to actually subtract equation 3. I'm going to do equation 3 subtract equation 2, and I will write that to the side. You can subtract in any order you choose, but choose it wisely so that you make sure that you make the maths easy for yourself, okay? Particularly if you're trying to do this without a calculator. So let's go through it. So we're doing equation 3, remember this line, take away this line, so it's back to front. 4x take away 4x goes 10y take away 3y is 7y, and 82 take away 33 is 49. Okay, usually you'll get a nice answer here, so normally it's a bit of a flag that something's gone wrong if you get something where this is not going to give you a nice number. So, excuse me, in this particular instance then we've got 7y is equal to 49. So just like when we solve equations, if 7y is 49, then we divide through by 7, and that means that y is 7, and there's our first solution. Same steps follow as in my previous video. So the next step, if you remember, we're going to substitute into equation. Now you can choose whichever one you want. I personally like to go back to my original first two, because obviously this one's now got bigger numbers, and sometimes you might have to multiply by something a lot bigger altogether. So I think it's easier to stick with the first two equations. In this case I'm going to substitute into equation number 1. I always like to write it out again so that I know I've got it in front of me. So 2x plus 5y is equal to 41, and then y is equal to 7, so 2x plus, now if y is equal to 7, 5y is 35, and that is 41. And if I then subtract 35 from both sides, remembering we're doing the inverse operation, if we take away 35 from both sides, we're left with 6, and then we divide by 2 to give us that x is 3, and these are your solutions. So x is 3 and y is 7. Now if you remember from last time, I had a little trick up my sleeve, which is to check your answer. So we're going to check in the equation that you've not used. In this case it's number 2. So I'm going to write it out. 4x plus 3y equals 33. Now x is 3, 4 lots of x is therefore 12. Y is 7, so 3 lots of 7 is 21. Does that equal 33? Yes it does. And therefore we've solved it, we've got it completely right, and we've managed to check our answer. So just one extra little step of multiplying one of the equations at the beginning, and everything else remains exactly the same as before.